volume is proportional to 1 over pressure. Volume is directly proportional to temperature. There we go. So volume is proportional to temperature over pressure. And so we get this relation V is equal to a constant times T over P. And then this can be simplified to PV over T is equal to a constant. But this gives us a new law that this is actually called the combined law, that P1 over V1 over T1 is equal to P2 V2 over T2. I can combine Boyle's law and Charles' law and do them simultaneously. And so let's look at a problem like that. So if a hot air balloon at 34 degrees Celsius with a volume of 185 milliliters and a pressure equal to 735 millimeters of mercury goes up in the air, what is the new pressure if the temperature of the balloon is negative 4.0 degrees Celsius and the volume is 108 milliliters? So for this one, same kind of thing. Let's find the variables. So P1, V1, T1, P2, V2, T2. So the initial pressure is 735 millimeters. The initial volume is 158 milliliters. The initial temperature is 34 degrees Celsius. Final pressure is don't know. That's what we want to find. The final volume is 108 milliliters, and the final temperature is negative 4.0 degrees Celsius. And so a couple of these I need to convert. So I will convert this one. I'm going to add 273.15, and I'm going to get, it's going to be 307.15 accurate to the ones place. And this one's going to add 273.15, and I'm going to get 269.15 Kelvin accurate to the tenths place. And then I want to rearrange my variables. So if P1 V1 over T1 is equal to P2 V2 over T2, and I want to solve for P2. P2 would equal P1 times V1 over V2 times T2 over T1. It's really important that you get these correct. If you flip these over, if you get T1 over T2 or whatnot, then it will automatically be wrong. So I want you to be very careful when you do that, right? So I'm going to multiply both sides by T2 over V2, and that's how I got that. And on this side, they'll cancel. So P2 would then be equal to, I'll plug in all these. So P1, 735 millimeters times V1, 158 milliliters divided by 108 milliliters. So the volume went down. That's going to cause the pressure to go up. And the temperature, where's, oh, T2. I need the 269 up here, don't I? And this should be the 307. The temperature went down. That caused the pressure to go down. But the volume shrinking is actually probably going to have a bigger effect. And that's going to be, I'm going to be stuck with 3 sig figs, 942 millimeters of mercury would be my final answer.